Unit 1, complex numbers. Section 1.1, so Unit 1, Section 1. Chapter 1.5 is the chapter in our textbooks, and we are doing complex number addition and subtraction. Our objective is students will learn how to use the imaginary unit I to write complex numbers and how to add and subtract complex numbers. So far, when you had a square root with a negative inside, we, the teachers, have said that there was no solution. And this is because we were operating on the real number system. After today, you won't be able to say that anymore because we are going to look at the imaginary number system and the complex number system. First, we need to figure out what an imaginary number is, so we need to talk about the imaginary unit. That is I, and I represents the square root of -1, just like pi represents 3.1415, so on. Okay, so it's like a variable, but not really a variable. It is a set number. It's the square root of -1. Remember from Algebra 1 that if you had two things being multiplied inside of a square root, you were allowed to separate them into two square roots being multiplied together. So we want to simplify the square root of -6. So what we want to do is think about the -6 as two numbers being multiplied. We want to take apart that negative sign. So we're going to think about it as -1 times 6. So it would be the square root of -1 times the square root of 6. And as we learned above, the square root of -1 is I. So this is I square root of 6. We put the I in front so that it doesn't accidentally slide inside of the square root, because that means something entirely different. When we write the I by handwriting, we use a curly I. Okay. And that's just to signify it's different than our variable I. Okay, let's try another one, the square root of -49. So we want to break apart that negative sign. So we would think of -1, so square root of -1 times the square root of 49. Again, the square root of -1 is I. The square root of 49 is 7. So this will be 7I. Okay, the square root of -48. Again, we're going to break it apart into the square root of -1 and the square root of 48. The square root of -1 is I. 48 we need to break up. We are going to use what is called our perfect squares. Okay? You need to ask yourself what perfect square is hiding in 48 or is divisible into 48. So to get our perfect squares, we're going to take our integers and we're going to square that. So 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25, and so on. Okay, so we want to go back over to our 48 and ask which number divides evenly into 48, and that is 16. Which one of these perfect squares? So the square root of -1 we're going to write as I. 48 we're going to write as the square root of 16 times the square root of 3. The square root of 16 is 4, so this becomes 4I square root of 3. Let's look at how our number sets all interact with each other. Our smallest number set that we know of is the natural numbers. And that is 1, 2, 3, so on to infinity. Okay, the next set of numbers are the whole numbers. This includes all of the naturals and the number 0. So 0, 1, 2, 3, all the way up to infinity. Then we have the integers. So -infinity, ... -3, -2, -1, 0, 1, 2, 3, all the way up to infinity. Next group is our rationals. Rational has the word ratio in it. And ratio means fraction. And fraction means division. So these are all the numbers that can be written as a fraction. So all the way from -infinity to positive infinity, some examples: -4/5, -1/2, 0, 1/2, 4/5, 3. 3 can be written as a fraction because you can put it over top of 1. So any of our integers, whole numbers, natural numbers, those are all rational numbers. because they can all be put over top of 1. Now, if it is not rational, we call it irrational. These are numbers like pi, square root of 2, square root of 3. These are numbers that cannot be written as a fraction. All of these numbers are called the real numbers, and this is everything prior to today. Okay? So all of these numbers that we just discussed are real numbers. Now, if it is not a real number, then it is an imaginary number. And these were the type that we were just talking about on our previous slide. So negative 3i, negative I square root of 2 are all examples of that. Okay, now there is a name for these all being grouped together. That name is called a complex number. So if a and b are real numbers, the number a plus bi is a complex number, and it is said to be written in standard form. So if we take a real number and add it to an imaginary number, we get the complex numbers. So the real part is the a, the imaginary part is the bi, so our complex is a plus bi. So for example, 3 plus 2i is a complex number. For all of these number sets, there are symbols because we don't like to write more than we have to. So the symbol for the natural numbers is a double-sticked N. If we are looking at this symbol in a textbook, it is a bold printed letter, N. Whole numbers, it is a double-sticked W. Integers, this one doesn't make sense in the fact that the whole numbers and naturals were just the first letter. Integers uses the German word to get its letter. So it is a double stick Z. Rationals is not an R, but we need to think back to that word ratio. And again, we said that meant fraction, which meant division. The answer to a division problem is quotient. So the symbol is a capital Q with a line in it. Now, either you are a rational number or you are an irrational number. So it's an either or situation. The way we signify either or situations in math is with a star or a C. So we use the Q with a star or an asterisk and or a Q with a C. It doesn't matter which one of those notations you use. For real numbers, we use a double stick R. And again, you're either a real or an imaginary number. So again, we're going to use this star and C notation for our imaginary notation symbol. Okay. Our complex numbers is a C with a stick in it. Looking at our sets of numbers, we want to be able to identify where our numbers belong in which set. So we want to look at what is the smallest set that a number belongs to. So the number 3. What is the smallest set it belongs to here? You can either write the word or you can write the symbol that I just showed you in the purple. Okay, it is a natural number, or you could simply write your N. Pi. The smallest set that pi belongs to is the irrational numbers, or the Q with the star or the Q with the C. 3 plus 2i. Those are complex numbers. So that's the C with the bar. Negative 5i. That's an imaginary number. So the R with the star or R with the C. Square root of 2. That's an irrational number. So Q with the star or the Q with the C. It's important to be able to identify these sets of numbers that they belong to, because as we go through this course, we will be seeing this works for the numbers on the real number system. This works for the numbers on the imaginary number system. So we need to be able to identify which set of numbers it is in. Okay, we want to be able to graph these complex numbers. So we're talking about the generic a plus bi. So if we have the a plus bi as our number, we can represent it as the point a comma b in the complex plane. And this is going to be where the horizontal axis is the real axis and the vertical axis is the imaginary. So if we're graphing 3 plus 4i on a coordinate grid, we have to label our axes and make sure you don't label them x and y. You're going to label them imaginary and real. However, with our 3 plus 4i, we are going to think of it as an ordered pair, and we pull the a and the b out of our complex number. So our ordered pair will be 3, 4. And then we graph it just as we normally graph. So the 3 is on the real axis, so we go over 3, and the 4 is on the imaginary axis, so we go up 4. Okay. All right, operations with complex numbers. Starting, we're going to start with addition and subtraction. Okay. Once all the numbers are simplified, you pretend the i's are variables. Okay, so, for example, 3 plus 8i plus 2 plus 9i. We're going to break these up. We're going to drop our parentheses, and we're going to look at our like terms. 3 and 2 are like terms. 8i and 9i are like terms. So we're going to group the 3 and 2 together, and we're going to group the 8i and the 9i together. Okay. So 3 plus 2 is 5, 8 plus 9 is 17, so we get 5 plus 17i. Okay. If we have subtraction, we have to take the subtraction sign and put it to both things inside of the parenthesis that the subtraction sign is in front of. So we get the first parenthesis, we can just drop it. So we have 4 minus 6i. The second parenthesis becomes minus 3 minus 8i. And again, we're going to look at things for like terms. So the 4 and negative 3 are like terms. The negative 6i and negative 8i are like terms. So 4 minus 3 is 1. Negative 6 minus 8 is negative 14. So we have 1 minus 14i as an answer. Now, I know that many of you can do this in your head, and as you get better, you will be able to jump directly from this beginning, our beginning part of the question, to the end very fast. Okay? But for right now, so that everyone stays on the same page and that we understand what we're doing, this is the way I'm going to do it in notes. Okay, if I have 3, same still holds true. First parenthesis, I can drop. The second parenthesis, the minus sign has to be on the 5i. The third parenthesis, because this is a plus sign, I can just drop the parenthesis. And then I'm going to look for my like terms. My 7 and 6 are like. My negative 5i, negative 5i, and negative 5i are alike. So 7 plus 6 is 13. Negative 5, and negative 5 are negative 15. So 13 minus 15i. And then your homework is complex numbers, graph and add.